Hello, welcome. Let me take off my mask. Today we are actually treating indices and then logarithm. As the topic says, indices and logarithm. So the study of indices is actually interesting as it helps us, it's actually a prerequisite stuff we have to know before we actually go ahead and study logarithm. So we'll take turns now and then we'll begin the study of indices. After that, we'll quickly move to logarithm, and then that will be the end for today. So today we're actually just looking at how indices is, how logarithm also is, and how we can solve questions about it, the inventors of logarithm, and all those who put things together to make this whole topic work for us. So we'll start with indices. The study of indices is really interesting as it makes it very easy for us to be able to write very huge numbers in very small form. Let's take something like a number like 1, 2, 3, 1, 2, 3, 1, 2, 3. This is mentioned as 1 billion, right? It's mentioned as 1 billion. The study of indices makes it very possible for us to be able to write this in an index and then an exponent form. So according to indices, if we want to write 1 billion in the index and exponent form, we'll do it this way. It is actually equal to 10 exponents, then you count the number of zeros there. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is equal to 10 exponent 9. So thanks to indices, we've been able to write a very huge number like this in a very simplified form. And that's really amazing. But for us to be able to easily understand what indices is about, we need to study some laws and then properties about indices. And that's what we'll quickly dive into from here. And before we do that, let's quickly look at something like this. If you have something like 2 exponents 8, 8 is too huge, something like 2 exponents 4, according to indices, we can write this as 2 times 2 times 2 times 2. So indices actually tells us how many times this called the index. That's where the name comes from. That's where the name of the topic comes from. That's the index. It can also be called the power. So the index, it can also be called the power. It can also be called the exponent. So the number 4 that is at the top here is actually 2 with a small 4 at the top. So this pronounced as 2 exponent 4. So the 4 has a name called either index, can be called power, it can also be called exponent. So when we look at the plural of index, the plural of index is indices. So the name of the topic we are studying actually came from the plural of this index. That's where the name of the topic came from. So let me quickly clean the board. So the 4 is called the index, and then the 2 here is called the base. Okay, the 4 is called index, and then the 2 is called the base. So if you have something like a exponent 3, a exponent 3 means a times a times a. That's by definition of indices. You multiply the base 3 times. So the exponent actually tells you how many times you have to multiply the base. If you have maybe 3 exponent 7, it simply means that you have to multiply the base 7 times. So this will be equal to 3 times 3 times 3. 1, 2, 3, 4, 5, 6, 7. So it means that you have to multiply the base 7 times. Good. So let's quickly dive into the laws and then the properties of indices. So we'll start by looking at the laws of indices. You know, it's very logical that whatever topic we study, as long as we're able to understand what the laws are about or how the laws go on with a particular topic, we'll be able to easily solve the topic. So we start by looking at the laws of indices. There are about, I think, 3 or 4 laws. Let's see them. So the first law, let's look at the products law. The products law. So we have something like a exponent m multiplied by a exponent n. So this is called the product law. We will multiply something like a exponent m by a exponent n. Now, according to indices, this has to be solved this way. You maintain one of the base and then you add the exponents. As simple as that. You just maintain one of the bases and then you add the exponents. So a exponent m plus n. So simple. And this is what we call the product law. You maintain the base, then you add or you sum up the exponents. Let's take a typical example of this. A typical example could be something like 2 exponent 3 times 2 exponent 7. So if we have 2 exponent 3 times 2 exponent 7, we do not have to go and say 2 exponent 3 is 8, and it's actually a long way. So according to indices, we just maintain one of the base here, 2, then we add the exponents or the index or the power. So that's going to be 3 plus 7. So 3 plus 7 is actually 10. So the answer for 2 exponent 3 times 2 exponent 7 is the same as 2 exponent 10. So in mathematics, we have something called LHS. So let's say 2 exponent 3 times 2 exponent 7 is equal to 2 exponent 10. In mathematics, we have something called the LHS. So this side. And then we have RHS. So the LHS means left hand side. So LHS means left hand side. And then the RHS means right hand side. So the R here means right. So for this equation to actually be true, or for the equation to be correct, the LHS will be equal to the RHS. Whenever for any equation we have the LHS and the RHS to be the same, then we say that that equation is actually correct. So when you press the answer for 2 exponent 3 times 2 exponent 7, let me quickly do that. So I believe you should have written this. So you can also equally get your calculator and then we solve this together. So 2 exponent 3 is 8. And then 2 exponent 7 is 128. And we are saying that the answer should be the same as 2 exponent 10. So let's see what's the answer for 2 exponent 10. That's 1024. So now we'll have to check, is this the same as 1024? Yes, 1024. If that is the case, then it means that what we've done is actually correct. So 8 times 128, that's 1024 equal 1024. So we say that since the LHS or the left hand side is equal to the RHS, which is the right hand side, then it means that our law is actually correct. Okay, let's look at another example where the exponent is actually negative. So let's take such an example. I'll leave this place so that if you want to write, you can write it. So I'll go to the other side. So let's take something like 3 exponent negative 10. Then we are multiplying 3 exponent negative 10 by 3 exponent 4. What answer are we actually going to get? So we do it the same way we learned. So we maintain the base, and then we add the exponents. That's going to be equal to 3 exponent negative 6. So the answer for this times this is the same as this. So that's basically what the first law is about. That's the product law. Whenever you are multiplying two numbers and they have the same base, you can add the exponents. If the bases are different, you can't add the exponents. Or if the bases are different, this law doesn't apply.